So it looks like we have Dr. Garima Williams. She's joined twice, right? I see Dr.
Right.
Garima Williams.
Right, ma'am. Like I am going to moderate this session, so I've joined in like with 2 devices, so that like if there is any internet glitch, so like I can manage it that way.
Okay.
So yeah.
So it's good that are there many women professors there?
Yes.
Okay, that's very good.
Yes, ma'am. Glad to meet you. I keep hearing about you from Dr. Chaturvedi, like all the time, like he praises you, how modest you are. I mean, like the way like you were following up for like even a Zoom detail and everything, like he is like so much in awe with your like modesty.
Right, and Dr. Atul, he asked me for WhatsApp, and I don't like using WhatsApp, but because he wanted in case something happens, I got WhatsApp this morning.
Oh, right. Glad, ma'am, that you have that now. So it would be easy for us to like connect better with you. So yeah.
Because remember, I'm security and privacy, so I don't like to use many unless I have to. I don't use anything. But then because you're like, because many in India before, so they asked, do I have WhatsApp? So then I decided I'll get WhatsApp.
Okay. Yeah, that's nice. So yeah. So I believe like Varun, so like it's time to start, right?
Yes, we can start.
Okay. So happy to share this Sunday morning with you all. Good morning, everyone. I, Dr. Garima Williams, on behalf of PSIT organizing team and technical sponsors, ISTE and IEEE chapters, welcome you all to the International Conference on Computational Mathematics and Engineering Applications 2022. I take pride in extending a cordial welcome to our venerated keynote speaker, Professor Bhavani Thuresingham ma'am. She is a fellow of ACM, IEEE, AAAS, NAI, IMA, Founders Chair Professor, Department of Computer Science, Founding Executive Director of the Cybersecurity Research and Education Institute, 2004 till 2021, Senior Strategist, Data Science and Cybersecurity, 2021 up till present, Co-Director of the Centers for Women in Cybersecurity and Women in Data Science, Eric Johnson School of Engineering and Computer Science, the University of Texas at Dallas. She is also a visiting senior research fellow at King's College, University of London, conducting research on IoT security, a member of the Scientific Council of the URI-FIA Laboratory at the University of Chiang, Cameroon, Africa, giving lectures on integrating machine learning and cybersecurity, and was a cybersecurity policy fellow at the New America Foundation, focusing on cybersecurity workforce development. Her research interests are on integrating cybersecurity and artificial intelligence, data science for the past 36 years. It used to be computer security and data management. Her 41-year career includes industry, Federal Research Lab, US government, and US academia. Her work includes intelligence community since 1991 and has given tutorials, courses, and seminars at several US Air Force bases, as well as other organizations around the world. She has received several awards, including the IEEE CS 1997 Edward J. McCluskey Technical Achievement Award, ACM Outstanding Contributions Award, the IEEE ComSoc Communications and Information Security 2019 Technical Recognition Award as well, Lasting Research Award, ACM SAC MAT 10 Years Test of Time Awards for 2018 and 2019, the IEEE ISI 2010 Research Leadership Award, Career Communications, and 2017 Dallas Business Journal Women in Technology Award as well, and the 2021 IEEE Cybersecurity Cloud Diversity, Equity, and Inclusion Award as well. She has been named one of the 500 most influential business leaders in North Texas in 2021 and 2022. She has written opinion columns in cybersecurity and data science for venues such as the New York Times, has participated in panels organized by Fortune Media, and has given interviews on cybersecurity to numerous venues, including Magazine and Women's Day. Dr. Bhavani has worked tirelessly to promote computer science to the female and minority communities. She co-chaired the Women in Cybersecurity Conference 2016 and delivered the featured address at the 2018 Women in Data Sciences. She mentors students from high school, BS, MS, and PhD, and out of the 25 PhD students, she expects to have graduated by 2023 and 2024. 13 are women, as well as those from American, African, Hispanic American, the LGBTQ community, and disabled communities too. She has also given keynote and featured addresses at numerous outreach events inspired by her visit to Nelson Mandela's prison cell in Robben Island, South Africa in 1999, and has recently given a series of inspirational addresses to motivate women and those from the underrepresented minority communities, including at events such as the Mariam Mirzakhani celebrations for women in mathematics and the ACM I Mentor workshop in 2021. Along with all these achievements, she is wonderfully modest a person. All this while, convener of the conference, Professor Chaturvedi, keeps talking about her that how sincere and dedicated she is towards her academic commitments. To quote a few, she consented to deliver this talk at Indian Standard Time, though it is 1 a.m. in Texas right now. And the way she herself was following up the organizing team to receive the Zoom link and everything, that truly made her all the way more inspiring. Keep being a cynosure to many like us, ma'am. So join me in welcoming Professor Bhavani. Over to you, ma'am. Looking forward to listen to your talk. Thank you.
Thank you so much, Dr. Garima, and for giving me that wonderful introduction. I got very embarrassed at all the things, good things that you were saying. And then I also like to thank Dr. Atul Chaturvedi for inviting me, and also Dr. Varun I just met. So thank you very much, everyone. And I'm truly honored to give this keynote presentation. So I'm going to share my screen. Yeah, I'm going to share my screen. Okay. So you can see this. You can see my screen, right?
Yes, yes.
Yeah. So my talk is Trustworthy Machine Learning with Applications in IoT Systems. Okay. So IoT, we all know, Internet of Things. So, okay. Okay, so participants can see my screen, but I'm unable to. What happened? Sorry about that. Something happened. Okay, let me see if I can move the. Earlier I was able to move it, but now. Oh, is it okay if I show it like this, or is it not okay?
Fine.
Okay, I'll try one more time and see whether it's going to work. Earlier it worked, and some more than now it is not working. Oh, no. Okay, sorry, my mistake. Sorry about that. It's working. I clicked the wrong button. Okay. So the outline of my talk, trustworthy machine. I'll first talk a little bit about trustworthy machine learning. What is it? An architecture. And again, to do machine learning, right, closely associated is big data, because you've got to train with big data, develop the models. So I'll talk a little bit about big data security and privacy, and then privacy aware quantified self. And then I'm going to talk about data science. So I'm using the words data science and machine learning, AI sort of interchangeably, okay, to mean the same thing, or even data mining. Although there are some differences, but I'm just going to use extracting this new information from lots and lots of data. So how do we apply that for cybersecurity? And then the biggest challenge that we are faced with right now is what happens, because we are all applying AI, artificial intelligence, for everything. So what happens if these AI techniques are attacked? And then I will talk a little bit about trustworthy analytics. So I'm going to try and finish all of this, the main technical content, try to finish this, probably take about 30 minutes in this. And then I'm going to talk about the application, the Internet of Things. The particular application, I did some work on Internet of Things, but now my focus is on Internet of Transportation, like cyber physical systems, transportation systems. Okay, So I'll talk a little bit about transportation system security and privacy. And then how can we apply part 1 to part 3? Part 1 is trustworthy machine learning. How can we apply that to Internet of Transportation? Okay, and I've got all these wonderful colleagues without whom I wouldn't have been able to do all this work. And also my former PhD student, Dr. Raul Quinones, and also Ms. Rhonda Walls, our project coordinator. So we all work together as a team. Okay, so now integrating cybersecurity and AI, ML data science. And this is what we call trustworthy machine learning. Okay, so now the question is, what is trustworthy machine learning? And that is, and this is not very easy, right? This is machine learning that has to be secure. What do we mean by that? Because these machine learning techniques could be attacked, cyber attacks. We are applying machine learning and artificial intelligence to many, many applications. And imagine if these machine learning techniques are attacked, it's going to be a huge problem, right? So handling cyber attacks to machine learning. Another aspect is, what about privacy? Because of machine learning and data science, data analytics, you can gather lots of data and then analyze the data and extract some new patterns. By extracting these new patterns, okay, you will be able to, it's a big problem there, because by extracting patterns, these patterns could be highly private, right? So these machine learning techniques have to be privacy preserving. And the machine learning techniques have to be accurate. They should have high integrity and produce correct results, okay? So that is another aspect of machine learning. And then the other aspect of machine learning is that they have to be dependable. What do we mean by dependable? They should be able to handle faults and recover from failures, right? And finally, what is really important these days is fair and unbiased. That means these machine learning techniques, people can train them, right, to discriminate against giving bank loans and so on. So they should not discriminate against the individuals. That is another aspect. But all of them have to be put together into machine learning. Now, it's almost an impossible task today. So I'm not going to, I call it trustworthy machine learning, but we are only going to focus on security and privacy. I'm not going to talk about things like accuracy, dependability, and being fair and unbiased, okay? But that's also, we've done some work and we have written some separate papers on that. And so that is sort of the problem that we are having, okay? So now we want to get into what is trustworthy machine learning. As you can see, machine learning, that is security, privacy, integrity, and availability on the one side. On the other hand, you've got fairness and unbiased and anti-discrimination and so on, right? All of that. And then so the machine learning has got different layers. So we have infrastructure layer. Our infrastructure layer is usually based on cloud. And then top of that, we have our big data management layer that is to manage massive amounts of data. And then top of that, we have machine learning layer. Machine learning is deep learning with decision trees, support vector machine, and so on. And then on top of that, we have applications. So our applications could include cybersecurity, because remember, we can apply machine learning for cybersecurity, and the machine learning techniques have to be secure. So we have applied this to IoT, social media, and so on. But the main thing here is security, privacy, integrity, availability, all have to be incorporated into machine learning, and they have to be fair. They should not be biased. They should not discriminate against school admissions or giving jobs or giving loans. So that's the key point. Okay, so I'm only going to focus on some aspects. So now we want to talk about privacy. Okay, so I said data mining, but it's essentially machine learning. So I believe I introduced the idea in 1996 at the IFIP conference in Italy, and then at the Pacific Asia Data Knowledge Discovery Conference, and that was in Melbourne, Australia. And then I call a landmark paper. The only reason I say landmark is because I was a program director with the US government. And so when you are program director, that means you give out all the funding and the money. And so when you are the program director, then you have to, people sort of follow the directions, right? So that was in 2002, and that spawned a new area of research. That means how can you have privacy and how can you also have data mining machine learning? So you have original data and then you add the noise, right? And then you, because the thing is you want to do machine learning, but you don't want to give out the fact that John Smith, right, has got diabetes. But you want to give other information. People who live in a particular part of Texas have got diabetes, because you need that for epidemiology, to develop cures and to find out who is ill and so on, which area. Because you might want to vaccinate them with, say, COVID, but you don't want to tell that a particular person has got COVID, right? That's the main thing. So you want to modify the original data, add noise, and then you carry out machine learning data mining, and the final modified result should not have changed much. So that's the main thing. So we did some research. I'm my first PhD student, a lady, Dr. Li Liu, and we focused on how do you do machine learning data mining, and at the same time, how do you ensure the privacy? So we call it privacy preserving data mining, or decision trees, privacy preserving neural networks. So we worked on privacy preserving decision trees, looked at perturbing the data, some special techniques. But now we have big data, right? So because of that, machine learning exacerbates, because of big data, there's so much of data, it has exacerbated privacy, right? Privacy gets much worse because we can now, there's so much data and we can apply machine learning, analyze the data. And so in 2014, September, I had a workshop and it was big data security and privacy. And then we presented our results in February 2015. And there were a lot of efforts the government funded. So what did we do at that workshop? Because of a lot of technology and applications, we can now capture lots of data, process, analyze large amounts of data for the various tasks, security tasks, because remember, machine learning can be applied for intrusion detection, anomaly detection, malware detection. That's for security. It can be applied for financial applications to give you stock market codes, make predictions. It can be applied for healthcare. So we are always using machine learning for everything now. But the task that we need, say for security tasks, right? What we figured, because for authentication, right? Even say like WhatsApp, so much information is being collected, right? For user authentication, we have access control, anomaly detection, monitoring the user, so inside a thread. So a lot of data is being collected about the person. But by analyzing and integrating the data collected on the web, you can identify connections and relationships and so on. So that's the problem we have, because we have lots and lots of data, several records. We can put all the records together, and then we can detect homeland protection, disease outbreaks, and so on. And the collected data, even if we anonymize it by removing the identifiers, but we can link all the data, right? Link all the collected data, and we can re-identify the people. So you have a record that is anonymized, and another record that is anonymized. We put the data, anonymized data, and be able to find out who these people are. So that's dangerous, privacy. And even authentication, access control may require detailed information. So a lot of private information. So our workshop focused a lot on privacy. Then we also, because if this information is stolen, then there's privacy breaches. And then another big problem, the biggest problem today, is what happens if these machine learning techniques are attacked. If these machine learning techniques are attacked, then no point doing machine learning, right? So instead of saying that you have COVID, it's going to say you just have a cold. Or instead of saying that you have diabetes, it might just say, oh, you just have some stomach upset or something like that. So we looked at what can we do? How do you secure the data? What about access control models? What about privacy techniques? What about how do you apply big data for cybersecurity, machine learning for cybersecurity? How do you do secure machine learning? At that time, we did not talk about trustworthiness in the sense accuracy, integrity, and so on, and fairness. Now we are trying to do all of that, okay? And that's why it's very challenging problem. Okay, so now privacy aware. So we started a project, and how do you do privacy, right? Because it's a big challenge. Mobile users, right? We have our smartphones, and so much of information is being collected. And so the psychologists have worked on something called quantified self movement, where it's a good movement, where you collect lots of information about people, right? And then you give them advice. Don't eat, like I eat, like I love chocolate. I like vanilla ice cream and milk chocolate. And I also really like lamb curry, okay? So if I'm eating all that, it will be nice if the refrigerator will tell me, my smartphone, send a message to my smartphone, and it can tell me, okay, don't eat this food, it's not good for you, right? But that is very good for our health, but our privacy is being violated because all this information is being collected, and they might send that information to the insurance companies, right? And they can deny us coverage. So that such data collection and sharing is being carried out without the user's knowledge. So data collected by device monitoring glucose levels, right? It can not only deny us coverage, it can also deny our blood relatives, right? Our children, grandchildren, and so on. Such privacy violations could easily get out of control if the data collectors could aggregate our financial data, healthcare data, and so on, put it all together, and a complete picture is going to be, everything will be known, everything about us. So to address these challenges, we need tools and techniques for privacy protection. So what did we do? So what did we do? We said, right, we are collecting health data, fitness data, location data, and so on. Some data is in the cloud storage. This is a smartphone, okay, or iPhone. Some data is in the cloud. We can encrypt some of the backup data. So what we are saying, our theory here is that whatever we collect, data collection, data storage, data analytics, policies have to govern. That means we need appropriate policies. Now, we are computer science, so we are not developing policies. So we are working with policy experts to develop the appropriate policies for data collection. That means whenever we go to collect data about an individual, we have to tell that person, we are collecting your data, we are using it for community healthcare or something, not to use against you. That's why we are using it. As soon as our project is over, we will not be collecting the data. Okay, so that is what we are interested, policy aware. And so, and we have developed the system. So I can send you one of our papers later on. So what is policy aware? That means as data collection, storage, and so on, some of the data in our smartphone, some data in the cloud, and based on access control policies, everything depends on policies, data collection policies, access control policies. So you can see here, this is our smartphone. We saw some of the data in the cloud. Some would be encrypted. We may not want to collect all the data because there may not be space. So if you're 20 years old and if you're pretty healthy, then it's okay. You don't need to weigh yourself every day, right? Even if you put on 3 pounds overnight, it's not going to kill you. But if you're 70 years old or worse, 80 years old, you shouldn't be putting on 3-5 pounds overnight because it's not good for the heart. So that way we can minimize the data collection, right? And another problem is what happens when the data is deleted, right? It's not like having our jewelry in the bank and taking away our jewelry. We don't know whether the system administrators or service providers are actually deleting our data, right? So we need delete policies. So some of the data could be in the cloud, some data could be modified. So anyway, I sent my presentation to Dr. Atul, so I'll ask him to share with the conference participants. Okay. So now we talk about how do we apply data science, big data to cybersecurity. So this particular work is joint work with Professor Latifa Khan, my colleague. And so what we do is typical, right? We use past data to build a classification model. Those of you who know machine learning, we predict the labels of future instances, right? And then that can help in decision making. So you may tell me, so what is the big deal? This has been happening for 25 years. We have been doing machine learning or data mining. The big deal is we have got large data streams, massive amounts of data streams continuously coming. It could be network data, it could be sensor data, it could be stock market data. So it's continuously coming. And so here we have network data is continuously coming, and we have to build a model. But so remember, this data is continuously coming. So one model is not sufficient because data is continuously changing. Today it will say buy Microsoft stock. Tomorrow it's going to be buy IBM stock. The next day it's going to be buy Facebook stock. So everything is changing. So one model is not fine. So we have to develop a collection of models. We call it an ensemble of models. That is the challenge because a lot of data is coming. So 25 years ago, we were doing this, but we only built one model. So we are building model in real time, and it's classification model, and it's real time, and models are updated. The old models, if it's Microsoft is no longer by Microsoft, we throw that model away and replace it with some updated models. There could be a human in the loop, but that's the challenge. And then what we do, the attack traffic, we block and quarantine, and benign traffic, we put it in store, and later on we can do some further analysis, right? So the data stream, continuous flow, very common in our connected world, massive amounts of data. And so we applied this also to insider threat. So very quickly, I'll go through what is insider threat. Insider threat is bad people pretending to be good people, right? So there are people we know, they're good, bad people, but they are working in the organization. They have all the clearances. They are pretending to be good people. And then they are saying, okay, they can do all kinds of bad things and go and get things and go and give the information to the adversary. That happens in the real world. That's also happening in our computers. So we have to detect these bad people, but they look like very nice people, right? They are part of our organization, or they are part of our processes. They look like a database process or a compiler process, but these are malicious processes. So what did we do? We applied machine learning, supervised machine learning like support vector machine, and unsupervised machine learning. We applied graph-based anomaly detection in some of our papers, and we found, it was surprisingly, the unsupervised machine learning performed actually better. Sometimes, right, when we apply machine learning, we don't really know why certain machine learning techniques are performing better. So because, that is why there's a whole another area which is called explainable systems. Whatever the machine learning is doing, it has to be able to explain why it's taking a certain approach. Okay, so that's still evolving. Okay, so our architecture, very briefly, inside a thread, there are all of these system calls, they're typing, and you take the I chunks, right? And that's a testing data, training data. You gather or extracting features. That's a challenge because you've got to extract the correct features. Extract the features, build an ensemble of models, okay? And then models are updated continuously. And then we applied number of learning algorithms, unsupervised and supervised. And then when the new chunk comes in, right, then we extract the features and then we do the testing. And then we say, and then we develop a model and then throw away the old models, right? Anything that is outdated, we throw it away. So that's what we applied. Okay, so that is now data science machine learning for cybersecurity. But remember, when we talk about trustworthy machine learning, this is a major aspect. Machine learning techniques could be attacked. What do we mean? Adversary is watching. He is watching, they are watching what sort of machine learning are we using, what sort of data we are using to train the models, and they could corrupt our data, they could thwart our models so that instead of saying by Microsoft, it's going to say by Facebook. Okay, so people can lose lots of money. Or instead of saying we have COVID, it's saying you just have a cold and we are not going to take any medication and then we could die. So adversary modifies data, but we have to understand the adversary. It's not concept drift, that means patterns changing. No, it's not learning online. Adversary is changing its behavior so that it's trying to hide. We have to be several steps against the adversary. So they can change our data during training time. They can test our model, change our models. So it becomes game. So look at this. This is a support vector machine, let's say. This is our boundary. On this side, we have red squares. These are bad instances. And the blue circles are good instances, right? But what the adversary is trying to do is push the red squares here. See what's happening. It is pushing 1, 2, 3, 4, 5 red squares. These red squares are below the boundary line. So when we look at these red squares, it looks like as if it's a good instance. These are good instances. They won't be caught. Okay. So as a result, some great damage could be done. So what do we do? So before we do anything, we have to understand the attacks. Okay. One type of attack is called a free range attack, where adversary can move the malicious data anywhere. The other is a targeted attack, where adversary moves the malicious data closer to the target. It's in our paper, the KDD paper, sorry, the paper I'm going to show you. So you can sort of figure out, learn what the attacks are. But what are we doing? This is the challenge. What we are trying to do is this. This is a support vector machine, right? Original boundary. We have the red crosses are bad instances. The green circles are good instances. So what the adversary is trying to do is to push these bad instances towards the side so that it won't get caught. As many bad instances are possible. What are we doing? We are trying to learn what the adversary is doing and move our support vector machine line, boundary line, to this blue line. So black dash line is a standard support vector machine. Blue line is the adversarial support vector machine. So once we move to this blue line, say, right, all of this, those days earlier, all of this would not be caught, right? So look, these are the bad instances and these are the good instances. So this is the support vector machine, original boundary line, okay? But by moving the original boundary line, by having the original boundary line, all the black pieces you see, they are going to show up as good instances. What are we doing? We are trying to do some mathematical computations and then moving this support vector machine to blue line. That means everything in between will be caught as bad instances. Now you can ask the question, why not move the blue line right here? All the bad instances will be caught, but imagine, if we move the blue line right here, right, then all these green circles will come as bad instances. That means we are going to have a lot of false positives. We don't want false positives. We don't want false negatives, right? We also want the results to be accurate. And so what is the optimum place to move the blue line? That is the challenge, okay? So that finishes one part. Another part we are trying to do, some people are saying that this is going to be a very difficult problem. You may want to, because machine learning techniques have to be secure, maintain privacy, unbiased, accurate, and so on. Computations, okay. Why not do things in hardware? That's what some people are saying. What do we mean by doing things in hardware? What we are saying is computations over big data may require massive computational resources in organizations, right? So third parties, we have to outsource a lot of the computation. So when we are using third-party servers, data becomes very corrupt, right, and untrusted. So there's man in the middle and so on. So what we are saying is Intel has given us a platform, SGX platform. How about using Intel's platform and to support the trusted execution environment? And so that's something we are doing. And then I was on a panel actually in India about 1.5 years ago, and there was a panelist from University of Oxford. She was saying, what about using formal methods for machine learning, bring in logical and formal verification techniques, and what about applying that for machine learning? So these are some of the things. We have not applied formal methods, but we have looked at the Intel platform. So for instance, the Intel platform here is this. So this is the Intel chip. I won't go into the too many details, but this is really more people are looking at it these days. So we take the machine learning code and then we execute the machine learning in a special location that is called the SGX enclave memory, the trustworthy location. So essentially we are saying, why don't we use hardware to provide security? Okay, but remember, it doesn't mean hardware is secure. hardware also can be attacked, but it can be maybe more secure maybe than software. So there are a lot of people now in cybersecurity working in hardware security. Okay, so that finishes sort of the technical content of trustworthy machine learning. And remember, I haven't gone into bias and so on. So usually for fairness, what we do is apply a fairness factor or a bias factor to modify. So for security, we are applying game theory. For privacy, we are applying privacy-aware data mining, so privacy factor. So imagine applying game theory, privacy, fairness, putting it all together, it could be an almost impossible task, but that's where the research is going. Okay, now I come to transportation, a particular type of internet of transportation. So Internet of Things. So here, IoT usually we mean like our smartphone talking to our Wi-Fi's and our clock and mail and Amazon and television and refrigerator all talking. That's IoT, Internet of Things. Transportation, cars talking to the trucks, talking to the roadworks and the trains and airplanes and all kinds of stuff. Okay, so Internet of Transportation, very briefly, right, lot of data, you know, the trucks carry a lot of goods, 63.3% of the freight of goods. AVs, autonomous vehicles, are not just ground, they are also air, like drones and airplanes, and sea. Sea vehicles are like what? They are like submarines and ships and boats. But apparently, the ground vehicles, the market, they have a partial automation of level 2, and aerial vehicles have more automation. Yeah, we didn't check with sea vehicles, by the way. Companies are investing heavily. GM spent so much in R&D, and they spent 1 billion in 2019. I need to get 2020 and 21 figures. While there's a lot of potential and the improvements, it can be due to the transportation, security and privacy. So without a doubt, machine learning is being applied a lot to transportation systems, but security and privacy are important. So what did we do? So again, we started looking at what are some of the challenges, right? So AVs, autonomous vehicles, evaluate their environment using a variety of sensors, camera, GPS, inertial measurement unit, LIDAR, radar, and so on. And some research has shown that sensors are susceptible to malicious tampering and GPS receptors are susceptible to spoofing. So vehicles should verify the veracity of the signals. But again, remember, IoT, there are tiny, tiny, tiny devices. So AVs rely on sensors to evaluate and interact with the environment. And as we said, sensors are susceptible to GPS spoofing and so on. But classical computing security is not going to work, like memory management, memory protection, cryptography, and so on. So we need to come up with some special techniques. And then real-time nature, because these are real-time systems, right? They have to gather information and send it right away. Otherwise, accidents can occur. It'll be too late. So AVs have to trust upon the environment, right? Sensor data, and there may be not enough time for verification. So this is a real problem. I'm not saying we are solving the problem, but we are trying to do the best we can. So what did we do? We built a physics-based reference monitor. Physics means, so my colleague, Dr. Alvaro, he's a control systems engineer and theorist, and he has a lot of knowledge of physics. Now, I did physics too, but that was really a very long time ago, mathematics and physics for my undergraduate, but he has been doing control systems and security for his PhD, so he really understands. And so the algorithm, so we looked at algorithm, we developed an algorithm, published in the top Usenext paper, security. We built a model offline of the autonomous vehicles' physical invariance. We implemented an online tool to monitor expected and observed behavior. And we raise an alarm if significant residual difference exists between executions. So offline pre-processing, online verification, anomaly detection. You could ask, what's the big deal, right? This is like what we have done 25 years ago. The big deal is the physics-based solution. 25 years ago, it was just for network security. But now we have to bring control systems engineers and physicists, right? So we have to develop all these differential equations and so on, and come up with the physical model of the control system of the autonomous vehicle. So offline pre-processing, the AV's invariants are calculated, well-known nonlinear models, accelerometer, gyroscope, and magnetometer apply on the X, Y, and Z axis. For the aerial vehicle, vehicle position and steering for the ground vehicle. So K is state, Y is input sensor measurements, and various moments of inertia, the X, Y, and Z axis, and so on. So we build that model. That is a challenge. And we also have to figure out what are the attacks. Okay. So online stage is we use an extended Kalman filter. Control system engineers have used it for decades, right? So we use this Kalman filter to predict the AV's physical behavior by estimating unknown parameters from noisy sensor input. So our algorithm is divided into two sections. One is for prediction, one is for correcting. And then the anomaly detection, we use the CUSUM algorithm, it's a statistical algorithm, to detect persistent attacks. Alarm is raised if the residual difference is larger than a predefined threshold. So again, some people would say, what's a big deal? We are using Kalman filters, it has been applied. But again, the challenge here is to come up with a physical model, right? And Kalman filters have applied for different types, have not been applied for, not much for this cybersecurity problem. So that's the new contribution. And that's our first step, okay? And so we tested this with aerial vehicle drones. So we use Intel ready-to-fly drone. Controller is the PX4 flight controller focused on, remember, GPS spoofing and for gyroscope attacks. The GPS attacks are detected in 0.2 seconds, the spoofing, and gyroscope in 1.5. Overhead is about 5.4. And the ground vehicle, we use cars, custom built on top of a Traxxas Ford Fiesta. Controller is ROX kinetic cam focused on detecting visual attacks, right? Overhead introduces 2.25. Each threshold produces a probability of false alarms of 2%. Okay, so that's the security part. But privacy is important. We really haven't done much on privacy because vehicular system privacy is becoming really important because people don't want to know, they don't want to show other people where they are going, their location. So how can we maintain privacy? So that's what we are saying. So beyond the security, right, transportation sector could greatly benefit, right, by using machine learning to support the infrastructure, communication between the various devices, motion sensors, and so on, because for inform them of traffic jams, reroute vehicles. From a user's perspective, privacy concerns arise from all the information needed by such a system, that, right? Because we have to use machine learning, but private information is exposed, right? Driving patterns could be, everybody could see our driving patterns. So legislatures, engineers, scientists should keep privacy concerns in mind. As advances in IoT become more prominent, this will improve the public perception and so on. So what are we planning to do? Okay. So I'll show you what we are planning to do. So privacy is important. So what are we going to do? So this is my last part of my presentation. So what we want to do, so remember our IoT, Internet of Transportation, we haven't really applied machine learning yet. So what we are current work now, that means until recently. Now we are saying we have to start looking at machine learning for transportation security. And so we are working on a proposal in that area. So IoT and transportation systems subject to attack, like any cyber physical system. A lot of streaming data, sensor data coming from all over the place. Transportation systems go electric. Everybody is saying electric cars, right? We need energy conservation, right? Because what could happen is that, and another big problem they are saying, and we are talking about it, the brakes. I was on some, some panel recently, and like, for example, the brakes could be attacked, right? And then it's going, if the brakes are attacked, and then imagine if you can't brake your car, apply the brakes, or your fuel gauge is showing that it's all fine, you have enough fuel, but then it might be empty, so you could get stranded. So we have to, and electric, we have to also conserve energy, right? So threats to security of such systems could cause massive damage. So the question is, how can we apply what I mentioned earlier, the machine learning data science for cybersecurity to catch intrusions and insider threat? how can we apply that for transportation security? Can we apply our stream analytics, stream machine learning, right? That we apply for financial data and telecom network data. Can we apply for transportation data? And what is the main question is we have to understand the nature of the complex transportation data, right? And we have to adapt our stream techniques to this transportation data. So that's where we are right now. And of course, adversarial machine learning. Machine learning techniques could be attacked. Internet of transportation will depend heavily on AI machine learning, right? Because we need that to inform the passengers and the drivers, the routes to take, where they can take rests, and what are some of the dangers. But remember, the adversary is following and really monitoring our machine learning models that we are applying to inform the passengers about the drivers about potential traffic jams and accidents and so on. They are following what we are doing, thwarting the models and attacking our machine learning. So the machine learning will say, okay, please go into this location. It's perfectly fine. We go into the location, there could be flash flood and we could get drowned and we'll die, right? So all these bad things can happen. So that's why adversarial machine learning, okay, we applied it successfully from simple attacks. How can we apply it to machine learning, right? Adversary will attempt to thwart the vehicle's learning process. So learning algorithms have to thwart the adversary. It becomes game playing, but what is a good game? What is the appropriate game for these transportation systems? It is zero sum, Bayesian, Stackelberg. Its research is only just beginning. Remember I mentioned to you, what about privacy? What we are thinking right now is to apply our policy-based, remember I showed a picture with a smartphone data collection like healthcare, social media data. Instead of that, our radar, GPS, camera, LIDAR, ultrasonic sensors, all the data is being collected. How? According to policies, data collection, data storage, data analytics, data and data sharing. So machine learning has to be according to policies. Collecting data has to be according to policies. Sharing data has to be according to policies. So some of the data could be in cloud storage, some could be anonymized. So again, privacy aware, policy based. So privacy aware autonomous vehicle. Okay, that is what we have to develop. And imagine, it's not standalone. We have to connect this to what we have here and what we have here. Okay, so, and these two. So that's the challenge we have. And imagine bringing bias into this. There could be biased algorithms. Okay, so my last chart. So there's a lot of developments in machine learning AI. It's exploding every application. And I'm looking forward to your machine learning conference in December. So it's being applied everywhere, including cybersecurity. So AI is applied for security, insider threat, and so on. Developments in privacy-aware healthcare, right? Managing one's life's activities. But at the same time, there's also IoT. We need IoT, right? So many gadgets for so many applications. Healthcare, we have pacemakers, we have, heart monitors, and this, that, and the other, and financial data. And IoT, what are the best options for, connecting our refrigerators to our microprocessors, to our smartphones and so on. Okay, so, but Internet of Transportation systems. So driverless cars are becoming a reality. Machine learning has to be applied. How do we ensure the privacy? How do we detect any attacks? And what happens if the machine learning systems are attacked themselves? And again, how can we bring trustworthy machine learning? Like, how can we provide like integrity, dependability, fairness? Don't discriminate against the drivers. You may have some preferred drivers, the machine learning algorithm to give some preferred drivers from a particular ethnic group, or maybe particular gender, male, and from a particular ethnic group, they will be given all the privileges and all the advice. Some other drivers and maybe some other gender like women, maybe they may not be given the advice. That's discrimination. So machine learning could do that. So these are the things we have to focus on. But remember, there's so many opportunities for research. Okay. And then I'd like to thank all my colleagues. And this finishes my talk. And I don't know the time, Okay, so we have maybe time for a few questions. I know Dr. Atul had, I tried to sort of finish it in about, I know we started about 11:35, so, sorry, 12:35 my time, so it's 1:20. So we have time for a few questions, right, Dr. Atul and Dr. Varun?
Yes, ma'am.
Yes, ma'am.
Yeah.
Like we're going to have that.
And so what I talked about, right, is a lot of topics, but there's so much of area for research, right? So and also remember, I addressed only two things, privacy and security. I addressed them separately, right? I didn't address secure machine learning and privacy aware machine learning. I addressed them separately. Then I also said there is fairness, and I'm addressing them separately. Right now, research is not integrating, right? We are developing privacy aware machine learning. We are developing secure machine learning. We are applying fairness and unbiased machine learning. How do you bring in fairness and privacy? If you focus only on privacy, fairness may get neglected. If you focus only on fairness, privacy may not be neglected. But if you don't focus on, say, security, then these machine learning techniques could be attacked, and there is no point even continuing, because if they are attacked, they won't be fair, they won't be private, right? So if you want to prioritize, I think different people will say different things. But what I'm saying, if you want to prioritize, security has to come first, because if security for machine learning is gone, that machine learning is not going to provide you privacy, because a malware can attack, and that machine learning technique is not going to be fair. So if you want to, some people will say, oh, but privacy is very important. But if security is not there, that means the machine learning techniques are attacked, then they are not going to provide you privacy. Privacy could be violated and fairness could be violated. Okay. So, but on the other hand, I don't know, it all depends on what your needs are and the application needs. So I really put more emphasis on security than others, but I have known that some others put emphasis on fairness and bias, because discrimination, and also on privacy. So yeah, so that sort of finishes my talk. And if there are any questions, I'll be happy to answer. But as I said, every little thing, everything that I talked about, that itself you could have a PhD thesis, but integrating all this could be like, this is like 10, 15, 20 PhD thesis that I put it all together.
All right. So Aditya, yes, ma'am. Yes, sir. Please go on.
I also want to ask one thing. Ma'am, recently we have started providing security to Internet of Things based architectures.
Yes.
So recently we have, for example, we have seen, we have modeled a intelligent elevator system, and this elevator system can be installed in various hospitals and big buildings. And these elevator systems have to decide on runtime, real time. So earlier anybody can move into the elevator system, but what we have incorporated, that is something close to multi-layer authentication. For example, only authenticated users or clients can move inside. So RFID tags, then OTPs, then various numbers. My question is, there are various constraints involved. First is memory issues, because these systems have very limited memory, and they always work in a low power, low bandwidth mode. So what else can be incorporated in these kind of access control systems in order to make these systems or protocols more robust and more customized?
Right. So lot of the things, okay, what we are saying is, if the memory is limited, right, you have to try and optimize the software, optimize the code to get the best performance. And then, I mean, if you can't optimize, right, if the memory is limited, okay, so a good example with access control. If you need to check all these policies I mentioned, right, million different policies, you may not have time. So you have to assign priorities. Okay, what are the high priority policies that you need to check? There's only so much time and there's only so much memory, right? So then as we bring in more and more, hardware is enhanced and there is also software to support the hardware, then you can improve. So right now, just like any real time, so I've been working in real time systems actually. for the government as early as the 1993. I got into real time security. I got in 1985, and real-time system in 1993. So the real-time systems of those days, right? We didn't have enough hardware, so we had to prioritize. We still have to prioritize, but we may be able to process more transactions today, or we may be able to control access. We may be able to have more policies, check for more policies. So there's always a trade-off. So right now, with what we have today, you have to optimize as much as possible. Look at the optimization code, optimize as much as possible. But then and then try to bring in more policies. So you got to check for some of the critical policies, you see, for the access control. So that's the only solution we have today. But things are going to improve without a doubt. And I think there was another question with Aditya. Yeah.
Yes, Aditya, go on, please.
Yes, ma'am. My question is that the applications, the antivirus software that we as well as the organization use to secure their computers, how are the ML as well as AI integrated within the software that we use to protect our systems?
Okay, so this is a very good question. Oh, there's a lot of research there too. Okay, one thing is, I'll come to your question in a minute, but you gave me a good idea to talk about some of the work we did. This antivirus software, right, may not, okay, so may not be able to, because they are always several steps behind, right? Because we get from McAfee or what, Symantec or whatever their product and put it, they may not catch all the latest malware, zero-day attacks. And remember, malware is changing patterns. Right? It's not, their code is changing constantly. It's like viruses, like the COVID virus is, we have alpha, beta, gamma, delta, Omicron, whatever, right? It's constantly mutating. Malware is constantly mutating. And while I don't know much about the COVID virus, the malware I know, malware is mutating. Malware itself is using machine learning to decide what is the best way to mutate. Do you see what I mean? So we wrote a paper where malware is applying machine learning to decide what is the best way to mutate. So, and then it's changing its patterns so that it won't be caught. So we also have access to all that machine learning techniques. So we can apply machine learning and then try to figure out how is the malware mutating. And then we have to try and come up with the fixes. So that's the one area that I did not mention, where machine learning is used by malware to decide how to mutate. Okay. Now your question is, how do we sort of integrate this machine learning into these antivirus products? So if these antivirus products, it's a good question, are there to detect this attacks, right? These antivirus products, now if you look at some of the recent products, I mean, they are applying some machine learning. So these machine learning techniques are also going to be incorporated into the antivirus products so that these antivirus products can detect the malware. Now remember, so that I'm talking about three different things now. One is answering your question, right? We develop the machine learning techniques to detect, and then we can maybe we can publish it outside, or we can work with a vendor like McAfee or whatever, and our malware bytes, and send and share with them our machine learning models and to detect malware, and they can incorporate that into their product, and then that machine learning algorithm in the product can then figure out, be able to detect the malware. That is one. Okay, that hopefully that answers your question. But again, the number two is that the malware is using machine learning to decide how it's going to change patterns. Okay, and that's worse problem. So that means whatever machine learning we have incorporated may not detect this malware because the malware has changed pattern. However, we have to develop machine learning techniques that's going to apply some machine learning techniques to figure out how is the malware going to change patterns. Okay, so I have to figure out, so I want to figure out about a person, like a suspicious person. I don't know whether tomorrow she's going to wear a black wig hair, or whether she's going to wear a blonde wig, or a red wig, I don't know how she's going to change. I have to apply machine learning to figure out how she's going to change, because she has applied machine learning to figure out what is the best way for her to change her hair so that I won't detect her. Okay, so I have to also apply that machine learning to figure out how she's going to change. So these are three different types of machine learning we are talking about. One is something, I call it more class A machine learning, where we apply machine learning to detect the malware, and we are not talking about malware changing patterns and incorporating that into antivirus. Number two is the malware is applying machine learning to figure out how it's going to change. And we are applying machine learning to figure out how the malware might change, so we can catch the automated, the modified malware or the mutated malware. Like we can, from Delta, we can go to Omicron, because if we have a way to figure out, oh, we are now in Delta. So Delta can come to Omicron. This is how it's going to change. We don't know that yet, right? So from Alpha to go to Beta to Delta to Omicron, if you know how these viruses are going to mutate, then we may be able to find the solution, like the Pfizer vaccine or the Moderna vaccine or all these Novavax, all these vaccines can then adapt, right? So that is really, so can machine learning help? So we can have all the virus data, all the people's DNA, and put all of this data together, and can we figure out what is going to be the next big mutation? If we can do that, then we can truly conquer COVID. Just like that, if we can apply machine learning successfully, how the viruses are going to mutate, then we can succeed. One more thing I want to mention, right? We talk about all these wonderful things. I am worried, and you have a conference in December on cryptography. I'm very worried with quantum computing. Quantum computing with quantum machines, I haven't done much research in cryptography. So with quantum computing, it can crack any code, right? So any encryption can be broken. That means we are not going to have security. On the one hand, quantum computing is going to help us with machine learning. Massive amounts of data, machine learning algorithms could be executed in milliseconds, where big supercomputers will take days and months to execute. And the code, the encryption, AES-256, currently these faster supercomputers will take millions of years to crack the code, 256-bit encryption. But with quantum computing, with milliseconds, it can crack the code. So if quantum computing becomes real, and they are saying 3 years, 5 years, let's say in 10 years, it could become real. It may not. People are saying 3 years, I doubt it, but in 10 years, say, then I don't know what, we won't have security. So there's a group of people looking at post-quantum, okay, post-quantum cryptography. One more thing I wanted to mention also, machine learning applied to encrypted data. That's another area of research which I haven't talked about. So these are some of the lot of exciting topics for all of us to work on.
Thank you.
So are there any questions? Or otherwise, I will probably see you in December, virtually.
So I saw one more raised hand. Nikunj was there. Like, Nikunj, do you have anything to ask? Yes, go on then.
Yes, ma'am. Ma'am, suppose there are two softwares. One is antivirus and one is the correct one that is used for protecting the antivirus, and both use the same technique. Then it is a win-win situation. How we decide who will conquer the other?
Okay, can you repeat the question? It's a very interesting question. I want to try and understand. One is?
And suppose there are two systems that one uses antivirus and one is used for promoting the virus. So, and both uses the same techniques of machine learning. And how we will determine who will win the race?
Oh gosh, that is a very, okay. So the antivirus is using machine learning, right? And one is using also the same machine learning algorithm to decide how it's going to attack. And they are both using the same thing. How is the game being played? So in this case, that's a very good question. I don't know the answer for this, because they are both using the same machine learning. They both know what they are trying to do, right? So who is going to win? because we are saying it's a game playing, because I want to develop a better machine learning than the other. And the other person, my enemy, is trying to also develop a better machine learning. If we are both using same machine learning, I know what he's doing, he knows what I am doing, and we might end up in a draw. It's a no-win situation, right? In the sense that he might get something ahead of me, then I will figure out and apply the same thing, and then I might thwart him, and then he's thinking, oh, she's applying the same thing. And so it could be like a draw situation. But that's a very good question that you have asked, because what we are assuming is that we are going to do something better than the enemy, right? So, and the enemy is trying to do what is better than us. That's where a game comes, because whenever we are playing a game, right, a tennis match or something, if you are just hitting the ball just over the net, that person is hitting and we are hitting, our opponent is hitting just over the net, and let's have a good time. I know how he's going to hit. He knows how she or she knows how I'm going to hit the ball. It's going to be a draw forever. We can go on. But to win the game, we have to come up with something better. Otherwise, it will be a draw. Nobody wins, right? So just like that game, we have to figure out, we have to do something better. So when we are looking at the research, but what you said is a good thing, because that is another case too, a case that we have to consider, right? But sooner or later, otherwise we'll be playing forever, right? Because I'll be playing over and he is trying to get it over, and very gently we are both playing, and we'll never win. We can go months and months and months like that. But we have to finish the game, right? So then somebody has to come with a new strategy. Just like that, it's a gameplay.
Absolutely.
That's a good question. Yeah.
Thank you for your question, Nikunj.
It could be a very close contest between two parties.
Yes.
Right.
Yeah, but next week Wimbledon is starting, so we will see, right?
Yes.
Somebody has to, right? Somebody has to, and I'm sure you all with cricket, right? We have to come. You can't just hit the, just use a bat and hit the ball like very gentle both sides, and we can play forever. Nobody gets out. Then what's the point in the game? It's just like that.
Absolutely.
Somebody has to come up with a strategy.
Somebody will have to take a lead in order to conclude.
Yes, exactly. Yes. Yeah. But that's a good question, Nikunj.
Right.
Thank you, ma'am.
Truly an insightful talk it was, ma'am. I'm sure participants have added a lot to their knowledge database. Grateful for your time and benign presence as well. So looking forward to see you in December conference. Thank you so much, ma'am.
And you have recorded that. So if you have recorded, please send me the link. Okay.
Sure.
Thank you very much. Thank you. Are you going to put it in? Yeah. Are you going to put it on YouTube or not?
Yes.
Okay. Thank you. But please send me the link.
Yes, this is already live on YouTube.
Oh, wow. Okay. Thank you.
So we have made this arrangement already. So we'll share the link with you.
Thank you so much.
Okay.
Thank you so much. Talk to you later in December. Bye.
Bye, ma'am.
Bye, ma'am. Thank you.
All right. So there is an announcement for all the participants. We will have a break for an hour. So the technical session will start at 12 now. So you people are supposed to be back on time, like be there sharp on like 12 o'clock, right? So participants, stay tuned by 12. All right, you can take a break now. Varun sir, you can like end the meeting.
All right.
All right.